All right. More on this Motorola phonograph amplifier, console amplifier. I've been playing around with it. I've got connected now to a 112 cabinet. I'm not sure at all who made the driver. The 12-inch speaker I'm using came out of an older organ. Oh, I say older. Maybe middle 60s, late 60s. It was solid state throughout. It had RTL logic in it. I'll give you an idea of the vintage. It's blue, I'm not sure. It has a ceramic magnet. It's a pretty good driver. Had good luck with it. So anywho, I think that organ output was rated 45 watts RMS, so this amplifier certainly will not hurt that speaker, that driver. No sort of crossover or anything involved with this. It just drives it directly. 8 ohm speaker. The thing works beautifully. Quite happy with it. But I kind of thought, it'd be nice to have some tremolo with this, and unfortunately there's no room aboard ship here to put it. So if it's going to have to be an outboard box, well, then the question becomes, well, how many connections am I going to have to make to this circuit to have, implement a tremolo? Well, it turns out not very many. Actually, I think about it, it's about 6. Yeah, no problem at all. That'd be easy to dummy in, and I wouldn't have to modify this in any way. Just an outboard box with the tremolo oscillator in it, and then it would just tack in to certain places. Some of which should probably be obvious. There's I'm going to zoom in on this a little bit later, but power supply up to this extra tube, of which right now I'm only using half of it. We'll get into that in a bit. But the power supply for the heater for this tube, the B+ supply, the high voltage for this tube, and the output, well, again, which we'll get into later, two connections into the amp that will cause this to modulate the amplitude, just as if you were turning the volume control up and down real fast, or at variable rates. Again, more into that in a bit. Yeah, I thought I'd show this whole business here first. Right now, I've got let's call it the output of this circuit, tied through this neon lamp, just a little light bulb, neon glow discharge lamp, to demonstrate first what this thing's doing, how it couples into cause tremolo. We'll get into in a minute, later. But I do want to zoom in on this. I'm going to turn the bright lights off so that this might show up a little bit better. So I'll do that. Big light off. I think that should work. And let's close in on this. Sorry about that. Yeah, should work. Yeah. All right. the circuit for this is nothing unusual or mysterious. I did not design it. I basically just copied what they did in the old Fender amps. Pretty much. That's the drawing I was going after. It's a simple phase shift oscillator. The load is this neon lamp. Oh, there's a resistor here too, but there's no need to worry about that. But this is a classic reverb oscillator circuit. And right now, the way it's connected, all it really is going to do is flash this lamp, this neon lamp. And it's deriving all of its power from the amplifier here. So let's turn him on, her on, and let things warm up. And you'll see this glow and begin to flash. Turn the volume down here. And that's all it is. And I included a potentiometer here. It's a trim pot, not a panel mounted sort of control, but a control nevertheless. Adjusting this, I can change the rate that flashes, and do have to be careful. There's 300 and some odd volts on some of this stuff here. So that's, I've not measured it, but that's about 10 flashes per second, 10 hertz, 10 cycles per second. You know, it kind of fast for what most people would use for tremolo. Most people. Turning this pot the other way slows the oscillator period down, and it's a couple of cycles per second, I estimate. This is just a tacked together breadboard. But some tweaking might be in order for a couple of these values. This pot, its limiting resistor, some of these other things, capacitors, to extend the range of this a little bit. I think I would like it to be able to go slower than that, and also faster than that. Well, faster than that. Don't know how well this is going to show up, the flash rate on this camera here, but I would like to hope you get the idea. A simple phase shift oscillator here. There's nothing mysterious. Just to point out the values I'm using here, if anyone is thinking of duplicating this, and you can find this stuff online. Just look up Fender Champ, Fender Vibrato, and you'll find it. I know they call it vibrato, but it's tremolo. Changing in volume, not pitch. The component values, I'll go through real quick. If you can match this to diagrams, which I'll probably post in comments, it's very simple. Let's see, so this blue wire here, right here, it's common, that's ground. It goes right to the chassis of this amp. The red wire is B+. I'd have to check. It's about, let's call it 360 volts here. Neon in series with a 100K that goes to the plate of one of the triodes in here. Doesn't matter which one, there are two in this tube. I'm only using half of it. I'm only using one triode. The other one's just not connected, but for the heater. The capacitor coming off the plate is a 0.02 microfarad. That's the first filter, high-pass filter, feeding through a 100K and then in series with a 2.2 megohm potentiometer. So the minimum resistance is 100K, the maximum is 2.2 meg plus 100K, so call it 2.3 meg. You could go higher and that will get you a slower oscillation frequency. This is handy, that's what I used. These two capacitors, oh, this, by the way, this 0.02, because it's seeing plate voltage across it, potentially, so to speak, that's got to be rated for it. This particular one's rated for 630 volts or some odd number like that. Plenty adequate. You could use a 200 volt rated cap there. These two, they don't even have a voltage rating on them. Both of these are 0.01 microfarad. Not close tolerance. K, I think, is 20%, plus minus 20%. It doesn't matter. It's not critical. And both of these are, being unmarked and being plastic capacitors, are probably 50 volt rated. Let's see. The two resistors associated with those two filters are both 1 megohm, nothing special. The cathode resistor is 4.7K ohm from cathode to ground with its attendant AC bypass capacitor across it. Negative side toward ground, of course. The value of this is not critical. I think I stuck well, let me look. I have to be careful. There is voltage on this. What did I put? I put a 33 microfarad electrolytic, obviously, in there. It's rated for 50 volt. It's not going to see much. It's not going to see 25 volts, so don't worry too much about that if you're going to do this. But do be careful. Don't touch. I'm touching this stuff all over, but I'm not grounded. I'm not going to put my hands in two places at once. You get out of that habit real fast. So you can see what this is doing. It's essentially a sine wave being fed current-wise through this lamp. And so it doesn't just flash on and flash off. It kind of, maybe you can tell, I don't know yet, but at the lower current, the glow is very small, and as the current increases through this, the glow becomes not to say brighter, but there's more of it. It more completely coats the cathode, which is the side in here. You know, there's two pieces in there, two electrodes. Only one of them is glowing, and that is the one that's more negative. So that's the cathode in this case. With AC across these, it appears that both electrodes glow, but that's really not the case. It's one than the other. But in this case, we're putting DC through it. The more negative one is going to have the glow around it. So, well, that's all well and good, but how does it affect the volume of the amplifier? And the way I'm doing it, and the way it's been done, is I'm using a photoelectric cell, a photoresistor. Simply, it's a resistor that its electrical resistance changes depending upon how much light it is exposed to. The package here is a hermetic one. I use this for a number of reasons. Chiefly, I have a crap load of them. And they have they're quite sensitive. The resistance across these two leads is very high. It's tens and 20s of megohms when completely dark. Even with a minimal amount of light such as this neon is putting out, the resistance drops considerably. They vary from part to part, but basically the assembly is this is in close proximity to the lamp, and then the whole thing is covered over to exclude external light sources from affecting this resistor. And some of the Fender amps, you know, it was exactly that. I don't know precisely which model of neon lamp they used. This one is an E2H, H being meant to be high brightness. And I think, in fact I'm pretty sure, those NE2Hs were doped inside with a bit of a lightly radioactive material. It extends the life of them and makes them fire at a lower voltage and more consistently light up. I believe I have some that are not doped, and they do fire at a higher voltage, and they are a different color, more pink rather than red, such as this, or orange. So anyway, that's how that works. And this resistor would tie into a specific place or places in the amplifier circuit to cause the amplifier to its gain to increase and decrease in time with this flashing. Very simple. There are other designs where rather than use a lamp, just use a resistor for the base, or I'm sorry, plate current, and then that varying voltage could actually be applied to directly to a grid, or grids on the output tubes, or maybe one of the preamp stages. Not the best idea. This is more expensive. This method is more expensive. It's not without its caveats, but for an outboard, which is what I intend to do here, for an outboard tremolo circuit, it's ideal because it can connect to just about any amp. All you have to do is pick the proper place to put this resistor across. Well, yeah, you might have to put a resistor in series with it to change the intensity of the tremolo or whatever. You know, a little bit of design work in there. But the basics are already working. All I did was tack this together. There was no modification of this amplifier at all to make this work. Just tapped into a place. So what I'm going to do, first I'm going to turn this off. I got my iron hot here, if not tangled. And going to disconnect this neon, and I'm going to reconnect this pre-paired neons. That'll work. Iron off. This pre-paired assembly here. Ignore this. The inside of here is the same as what you just saw. It's a neon lamp connected here, and a photocell kind of oriented this way, the leads bent over, and covered over with an opaque, more or less, shrink tubing, just to hold the thing together. So once this energizes, the lamp inside of here will be flashing and pinging upon this, or a photocell, which is tied in to this amplifier. I'm gonna ease this back out because there's really nothing to see up close. Sorry about that. Oh, I think I'll put the lights back on. There we are. Famous words of Mo Howard. Okay. Okay, so sorry about the delay. Flipper on. As I said, I'm not playing through this lab tech speaker. I've got her connected to a 112 cabinet. This thing is quiet. Makes me wonder if it's even working. Yeah. Hear that? These phenolic wafer sockets. I did repair that one and cleaned it, and it's still dodgy. And yet these above board normal phenolic manually sockets are perfect. Stupid, stupid, stupid wafers. Anyway, I can't see it, you can't see it, but I'm sure this lamp and this neon inside of here is flashing away. Right now, this is disengaged from the amp. I've got my guitar here already, presumably anyway, plugged in. That's volume's all the way down. Turn the volume up. So, amp's working. Very, very quiet. Now, I've got the because this thing has an RCA input, I've got it clip leaded from an RCA output to a 1/4-inch phone plug, of course, for the guitar. So there's a little bit of noise pickup, buzz, not so much hum. So that's without any influence from this tremolo circuit working. A little bit more technical. I coupled this in through a fairly large capacitor. That's a 10 microfarad at 100 volt capacitor. You can couple it directly the way I am, which by the way is going right into the grid of the phase inverter. Phase inverter, of course, drives the two output tubes 180 degrees out of phase. So I'm just modulating the gain. I can go directly, but I like using the capacitor so it doesn't upset the design currents into and out of the phase inverter. Other than the modulation. In other words, by putting this DC blocking capacitor, I'm not DC biasing the tube incorrectly. You can, and it will work, but why do that? So, this is without the wobulator connected. Right? Now it's connected. Now I have no control here over the depth of tremolo wobulation. Oh, it'd be very easy to do. You just put a pot in line with the this capacitor, or some other means of doing it. You could tie the photocell, this thing, you could tie it directly across the input or of the amplifier, or let's call it the output of the guitar. The same thing will happen. You might not get the same depth, and the tone might be a little different, but the same purpose is served. Now, I'm handling a guitar which is, by all intents and purposes, at ground potential, so I'm not touching anything metal here while I'm doing this, but I would like to adjust something, so we put the grounded guitar down, and I'm going to shift this pot all the way up the other side, leave that alone, and you get the idea. Put the guitar down, the ground, touch the high voltage crap, and set the modulation rate to something about which most folks would enjoy. Tremolo makes you sound good even if you ain't, in my humble opinion. So I am going to make a more permanent version of this, and I'm going to do it in a way that it will work with just about all of my amps, these tube ones. I do not use solid state guitar amps. I won't do it. They're awful. I have a couple and they're terrible. So that's the plan. Just thought I'd go over some of this, cover it, and hopefully not shock myself somehow in the process. See it.